Look at a modern commercial airplane. Fully loaded, it can weigh over 100 tons. That is heavier than a whole fleet of semi-trucks stacked together. Getting that much mass off the ground is a triumph of engineering. To stay in the sky, these machines have to master the specific physical laws of the atmosphere. Once a plane is off the ground, it enters a constant, invisible tug-of-war. The air around the aircraft pushes and pulls it in 4 different directions at once. Lift pushes the plane up, weight pulls it down, thrust drives it forward, and drag holds it back. To get that metal giant off the runway, the force pushing up has to overpower the force pulling down. Generating that upward force requires the aircraft to first move forward at high speed. The engines provide this power, pulling in massive volumes of air and expelling it with incredible force. This aggressive forward push gives the plane thrust. As thrust drives the plane forward, the air hits the wings. If you look at a cross-section of a wing, you will notice a specific geometry. It is curved across the top and relatively flat along the bottom. That shape causes a physical reaction. When the air splits at the front of the wing, the air traveling over the top curve has to move faster than the air moving underneath. Faster-moving air creates a drop in pressure. This creates a low-pressure zone on top of the wing and a dense, high-pressure zone trapped beneath it. Nature forces high pressure to seek out low pressure. The dense air underneath surges upward, shoving the entire wing into the sky to create lift. Lift is the result of a strict chronological sequence of events, starting the moment the pilot engages the engines. The engines generate enough thrust to overpower the drag of the air, allowing the vehicle to accelerate down the runway. As the plane hits a specific speed, the volume of air moving over the wings builds a pressure difference strong enough to counter the plane's total weight. When the lift surpasses weight, the aircraft detaches from the concrete. Consider a plane cruising at a constant speed and a constant altitude. Which of these forces are equal in that moment? To maintain level flight, thrust exactly matches drag, and lift exactly matches weight. The forces reach a state of equilibrium. When an airplane is cruising, the engines and wings are constantly working to maintain that balance against gravity and air resistance. These are the rules of the sky. To accelerate, thrust must beat drag. To climb, lift must beat weight. To hold a steady course, you lock the forces into a perfect stalemate. The aerodynamic principles governing modern jets are the same mechanics that allowed a wooden glider to lift off a beach in 1903. When Wilbur and Orville Wright took flight, they proved that a machine could sustain itself by balancing these specific mechanical laws. Aviation is the calculated manipulation of air pressure and thrust, turning the sky into a pathway for the heaviest machines we have ever built. Let me know in the comments, what